Thank you. Thanks, Derek. I appreciate the opportunity to come speak to everyone this morning. Hope everybody had a good breakfast. Lots of energy. Are you ready? Anybody? All right. Thank you. But you're with me, so you have to do that. So I'd like to make this interactive, if possible. I'm hoping to give you a little bit of a visibility around issues with audio, within conference rooms specifically, but also just in general as far as communication goes. Going to get a little technical, so hopefully you come away with a little more knowledge associated with audio and audio fatigue, and what the impacts are as to why that happens. It's a real phenomenon. It's not something that people just sort of imagine. You really do get tired associated with certain aspects of audio today. My name's Tim Root. I'm the CTO and EVP of Business Development at Revo Labs. A little bit of my background, I go way back in the video conferencing industry. If people remember Polycom, PictureTel preceded that. I was at PictureTel for a lot of years. I ran the audio video development teams. I was a CTO when we sold it to Polycom. I was on the CTO of the video division at Polycom for a little while, and then did some startups, etc. Joined Revo Labs 4 years ago, and have really had a good time working with the team there. It's been a lot of fun. So let's just jump right into it. So audio fatigue, also known as listener fatigue. There's been a tremendous amount of research on this in this subject for hearing aids and that whole area of the quantifiable psychological perception of sound. There are groups that look at this really for that individual as you have hearing loss, and what's the impact of losing frequency content associated with speech in your hearing. And that's a big driver and is part of the fundamentals associated with conferencing and having fatigue around the same principles. So one of the telephony environments, if people don't realize that 3.4 kilohertz is the standard analog fidelity. It's the same level of frequency you get when you're using a cell phone. There's been a lot of improvements to that with codecs going to 7 kilohertz. So one of the big things was Skype, when it first came out, it actually has 7 kilohertz of fidelity. It actually sounds better. And that was a big part, so people don't necessarily know that, but that was a part of driving people to use it. Hey, this sounds different than what I was used to. And I'm going to go into the difference between those fidelity ranges and why it impacts the fatigue factor when you're on calls. First, a quick demo. Hopefully you can hear the difference between these two. So narrowband is defined as the 3.4 kilohertz fidelity range. That's what you're used to hearing on a traditional analog telephone call.
Dorothy lived in the midst of the great Kansas prairies, with Uncle Henry, who was a farmer, and Aunt Em, who was the farmer's wife.
So that's the narrow band of that recording. Here's a wideband, ultra-wideband.
Dorothy lived in the midst of the great Kansas prairies, with Uncle Henry, who was a farmer, and Aunt Em, who was the farmer's wife.
So let me play the narrow band again.
Dorothy lived in the midst of the great Kansas prairies, with Uncle Henry, who was a farmer, and Aunt Em, who was the farmer's wife.
So what you're missing there is all the frequency content above 3.4 kilohertz. And it significantly impacts how your brain is used to hearing speech. You don't necessarily know that when you're on a phone call, but your brain knows it, and it's trying to process this limited range of speech coming towards it, which is totally unnatural from when you have a face-to-face conversation. What it's like is having a picture and losing all the high frequency content. You can see it. There's something there. You know that's an image of a person, but you've lost a lot of the extra detail that gives you the additional information, and that makes your brain work harder to actually understand what is that. So you actually have to consciously then spend more energy. So this is an example of where that frequency content lives. So what you have is the high frequency sounds. So when you're above 4 kilohertz, your sounds of F, S, and TH do not exist in a narrow band call. So you never hear those sounds because doesn't get through. So now you're trying to process words that have those letters in them. And your brain actually has to be thinking and replace where those sounds were. Now you can do that, you get context, and you have other cues within language that help you to understand what the word should be, but you're actually physically not hearing those sounds. So words like there could be here, right? Tear, ear. It's part of the how your brain has to actually start to do more work. And over time, an hour, couple hour call, you're constantly working harder to understand the language. You add to it somebody with an accent on the other side, and now you're doubly working, and you're really trying to understand what is this person saying. And it's not imaginary. You know, I'm sure all of you have been on conference calls and you've been exhausted when you get off the call. And it's not just because salespeople were on the call. Right? It's a real phenomenon that you physically were working, your brain was working, and it takes energy out of your body. And you extend that to 8 hours, and it's a really long day to be on a narrow band conference call and actually come away from that with a lot of energy still, because your brain is constantly trying to fix what it's hearing. So I think everybody understands that. You've lost content. Now, what else impacts your ability to get tired in a call? Another big part of it, you can't hear the person. So here's another aspect of sound and how sound propagates in a room. So every doubling of distance with speech, you lose 6 dB of energy. And it's just the principle of throwing a rock into a pond, and then all the ripples go out over time, temporarily. They're extended. It's the same idea with speech. So if I didn't have this microphone, but coming out of these speakers, every time the distance doubles, the energy level goes down because the waveform propagates out. And you're stretching that waveform. So what's that mean in the real world? I'm in a conference room. I put my speakerphone in the middle of the table. If I'm talking, typically about 70, 75 dB would be a normal speech level for somebody talking towards the speakerphone. If I'm 4 feet away, at 1 foot would be 75. So 2 feet, it's going to be 69. At 4 feet, I'm at 63 dB. 63 dB is fine. That's a pretty good level. The microphones are going to pick it up. But what actually starts to complicate when you move further away, and you also have somebody that maybe is a quiet talker. It's not unusual for somebody to tail off on their words a little bit towards the end, start to go from 75 down to 60 as they finish their sentences, or just somebody who has a quiet voice. Now you add the noise floor. So I'm sure all of you have had to deal with the fan kicking on, the heat kicked in. The ambient noise floor in a typical room is going to be in the 40 dB range, just on average. And then you add some ventilation system kicking on, you'll easily see that up in the 50 to 55 dB at microphone level. So now the speaker in the room is competing with the sound level of the noise that's also in the room. You get somebody at quiet talker, 60 dB, and they happen to be 8 feet away, the actual level at the mic on the table is in the noise, could be very easily in the noise level of the room. So now what happens? So now you have to start looking at, how do I fix that? And in the speakerphone technology at Revo Labs, we have the same algorithms. You start to look at an AGC, you start to look at noise suppression, and you're trying to reduce that noise level so that speech level can be pulled out. And that works very well, but it does introduce artifacts. So now you have great audio that you've taken from the speech. You've tried to improve it so you can pick it up in the room over the noise level. So you've done some enhancements within the algorithms. What those enhancements do is add some artifacts. It's just part of how the algorithms work. You're always going to be introducing additional artifacts. Goes back to the original problem. Now I can, on the far end, not only do I have, say, narrow band, it's difficult to hear, but I also have introduced, I've lost certain letters, now I've introduced artifacts on top of that. So you're not getting this clean speech, you're getting something that has artifacts, and I've lost a bunch of letters. I get more tired. Now I'm more tired. My brain's working harder. I have to now start to distinguish each of these words. A little bit more difficult through the process. I just want to point out this is a big issue with ceiling mics. Not only is it they're higher in the room, they tend to pick up more noise, but it's also the distance between everybody at the table. So it's one of the reasons at Revo we go back to saying, you know, let's put microphones as close to the speaker as possible to eliminate that distance. So the algorithms don't have to introduce these artifacts. Another component to it, so reverb in the room. This is a giant room, right? Tremendous amount of reverb. So when it comes to sound, reverb tends to be worse, well, it's not tends to, it is worse with low frequency content. So low frequencies disperse in all directions. You have a subwoofer, there's no directionality to a subwoofer. All those low frequencies just go everywhere. As you get higher frequency content, it tends to be, it's very directional. Higher frequencies get more directional, more narrow. So if you have a high reverb room and you have a narrow band call, you're basically driving all of this low frequency into the worst case scenario. So you're getting a lot more reverb with the low frequency content. If you had ultra wideband or wideband speech, now you actually add some high frequency content, which will be much more directional. Your intelligibility would go up because it's difficult. That high frequency content will not have as much reverb as the low frequency content does. So the room space, the whole low frequency narrow band, and makes it worse for the intelligibility in the local side of the room because of the reverb. And then microphone types. So omnis, we're big proponents of directionals. So if you're using an Omni microphone, you have a tendency to pick up everything, right? There's no directionality. They have a lot higher noise floor because they're going to pick up all the noise in the room. You can go with directional microphones. You get a very narrow beam. They tend to be much quieter as far as noise pickup in the space. So you're adding all that together. You get better frequency content with wideband. It eliminates a lot of these issues with reverb and also pickup. Does that make sense? Who wants to call bullshit? Anybody? No? Okay, I must be doing okay then. Okay, so I'm going to change a little bit just because I couldn't do this without a little bit of a sales pitch on Revo Labs. Okay, so Revo Labs, what we focus on is trying to solve a lot of these problems. So the general target here is I strongly recommend, and I know it's difficult, but as you're transitioning your IT infrastructure, look at going to wideband or even ultra wideband solutions. And one of the things we did at Revo when we looked at the market, say for speakerphones, this is our UC1000 product, 500, 1500. We looked at the reproduction side as well as the capture side of the speakerphones. And I came out of Polycom. I know that really smart people there, good technology. But a lot of what the Polycom speakerphones are focused on is the pickup side, not necessarily the reproduction. So if you were to pull apart a Polycom, you'd see a little tiny 2-inch driver. And it was designed originally for narrow band audio. That was their market space. That's what they dominated back in the 90s when they came to market. So what we did at Revo was we designed the speaker first. as well as the microphone pickup. So we put a real speaker into our speakerphone. That's actually our tagline. First company put a speaker in a speakerphone. Kind of obvious, but we put a tweeter to get you that high frequency content, because as things are moving from narrowband to wideband, that helps with the fatigue issues, but also just a better experience. You need reproduction. You need products that can give you the reproduction and give you the full fidelity on both sides, not only pickup, but also on the speaker side. Put a little more air underneath it so you can get better low-end performance. We actually hired in some guys from Bose that do speakers, and I know the line Bose, no highs, no lows, but these guys were good. They knew how to do speaker design. So this is our first product to market. We're very proud of it. So we'll pass that around and check it out. And this is the dialer. So we went with a tethered dialer as an option, so you don't have to, we call it the Polycom grab. You grab the thing and you pull it, the phone towards you, and then dial, and then you push it back. So now you just grab the dialer. Tether, it's easier. Goes on both sides. So we, in addition to this, just background on Revo, we were acquired by Yamaha about 2 years ago. So we are a subsidiary of Yamaha Corporation of Japan. Phenomenal audio technology, incredibly smart people. And we are merging our product lines with the Yamaha team, and we'll be seeing a lot more products coming out where they have Yamaha technology expertise into the RevoLabs products and vice versa. So we're working very closely with that group. The other thing we've done as a company is we are building, I don't know if everybody knows this, RevoLabs builds the Cisco 8831. So that is us. So they had a great relationship with their previous vendor for 10 years, but they weren't getting the next generation of technology into the market, and they were frustrated, so they went and looked at all the vendors that had the capability of doing speakerphones, and we won that business. So the echo cancellation, all the audio subsystem, we actually manufacture it for them. We just put their name on it and they ship it. That is the similar technology that we have in this product, except this is the ultra wideband version. They just have the wideband version. So we run this at full 16 kilohertz echo cancellation, audio processing, etc. on the UC family. And as everybody probably knows us from RevoLabs past, we're in the wireless microphone business. So this is our third generation technology. Does everybody know the RevoLabs name? Do you know the brand? So we do wireless mics. This is where the company was originated. This is our third generation of the products. And again, this is the mantra was put the mic in front of everybody that's speaking. So you have close proximity to pick up. Some of the highlights of this product, we have replaceable AA rechargeable batteries. So you never have to worry about batteries. Just go for $8, go down the store and buy a new one every year. 20 hours of talk time with these microphones. Little gooseneck directional. This is the regular directional. We can support up to 70 microphones in an area, 300-foot area. So we completely redesigned the architecture. Full, 20 kilohertz audio fidelity. Really fantastic product. So I encourage you to come over to the booth and check it out. We're just around the corner. Any questions on Revo? So one last point, sorry, I'm going too slow. Many people don't know this, but we are the second leading manufacturer of speakerphones now in the world. So compared to Polycom, this is a Frost & Sullivan report that just came out. So between us and Yamaha, we're at 17.2% of the market. So we're really doing very well in driving our technology, and really we're winning because of the technology capabilities. So just in closing, avoid long calls with salespeople. First step. Narrowband, high fatigue, wideband, a little bit less, ultra wideband is the way to go if you can get there. Different UC applications obviously are there. A lot of the phones BBXs are getting there as well. And then distance to mic, noise in the room, all those will play a big part of your ability to not be tired on the far end. Any quick questions? No, we're going to do it in the party room. Okay. Chit chat. All right. Thank you very much. I appreciate it.